And hello all, Mr. Cowan here to help you with Unit 7, Lesson 3, Multiplying Powers. Goal for today, as you can read it with me, let's explore patterns when we multiply powers with the same base. Remember that vocabulary base. Page 839 is your warm-up. Please pause the video if you have not completed it already. Pause the video, do the warm-up, and come on back when you're ready. Noticing how this one is which expression does not belong. This is one of those, well, you may choose as long as you can explain and give some reasoning. Perhaps you chose A, being the only one with expanded form. Perhaps you chose B, being the only one with a single power, single base, single exponent. Maybe you chose C, two powers that are then multiplied together. And perhaps you chose D, the only one with no powers, no exponents at all. Although theoretically, if you don't see it, it does have a 1 up there. But again, no right or wrong answer for the warm-up. Keep that in mind. Homework check if you'd like to check. Go ahead and pause the video. Come on back when you're ready. That was page 837. Here's page 838. Pause the video. Come on back. Remembering, please, our vocabulary. A power is the whole thing altogether. The base is the number that is repeatedly multiplied, and the exponent is the number that tells you how many of those we should multiply. Sorry about the X, it really should be a multiplication dot, right? Expanded form means take that base and expand it to show every single repeated factor. And remembering that equivalent fractions, or equivalent expressions, multiplication is commutative. So you could say that the expression 3 times 5 is equivalent to the expression 5 times 3, and so on. All right, you're going to get a card sort at this point, where you're going to ask the guest teacher or Miss Moore for your cards. Take each card, put it in expanded form, and when you're ready, go ahead and record which card goes where into your booklet from page 840. Okay, when you're ready, go ahead and pause the video. Come on back when you're finished. Activity 1, ladies and gents. Let's go ahead and review some answers. I'm going to make this a little bigger. First case first, I see the power of 10 to the second, thus 10 to the second power, multiplied by 10 to the third. And that, in turn, would be equivalent to the expression 10 to the fifth power. Onward we go. 10 to the fourth, 1, 2, 3, 4. 10 to the third, 1, 2, 3. And of course, if you multiply all those 10s, 1, 2, 3, 4, 5, 6, 7, multiply 10 times itself 7 times, verifies 10 to the seventh power. 10 to the third, multiplied by another 10 to the third, should match up with 10 to the sixth. Then we have another 10 to the third. I found this interesting. They both start with 10 to the third. And yet, how are these expressions different? This guy's got 10 to the fifth. Does that mean the answers are the same or different? Well, in this case, 1, 2, 3, 4, 5, 6, 7, and 8 explains that 8 exponent. Last but not least, 10 to the second multiplied by 10 to the seventh should match up with the following expressions. I'm wondering if you notice some patterns. Given the guest teacher, if the guest teacher is trusting you, that trust is an important thing. You're welcome to pause the video, talk to your partner. What do you see? What do you notice? Meanwhile, we're then going to go on to the next page. We don't need the card sort. So allow me please to begin, and then you can carry on with the rest. The table shows similar expressions as in activity 1, but now with bases other than 10. So we have numerous different bases. We have a 2, we have a 3, we even have an A. Our goal is to complete the table to explore patterns among exponents when we are multiplying powers with the same base. I'm going to put a star there and a star there because I know perhaps some people just use the word add. Now, in the proper context, that could be used correctly, but I just want to reemphasize today is all about multiplying powers so long as those powers have the same base. For instance, 2 to the third and 2 to the fifth would then be equivalent if I'm going to write this as a single power. The base is still repeatedly multiplying 2, but now we have 1, 2, 3, 4, 5, 6, 7, and 8. So those are all equivalent expressions. At this time, I'm going to ask you to pause the video, complete the rest of the table, including number 2, what patterns do you notice? And then I think you guys should go for the are you ready as well. Let me go ahead and do this one, and then you can pause. Write whole numbers 0 through 9 as exponents so that the 3 expressions are equivalent. So I'm going to write this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here's what I'm going to do. I'm going to come up with 1. So let's say I use the 9 here, 5 to the 9th power. I need to come up with equivalent expressions that would give me 5 to the 9th. Well, I believe that if I multiplied 5 to the 4th and 5 to the 5th, if I pictured all those 5s out, that it would also be equivalent to 5 to the 9th. So I'm going to insert a 4 into that blank, a 5, but I'm no longer allowed to use those. So what other numbers could I put in the middle blanks? If I started with a 6, I could also do a 1, that would be, and then, oh, check this out. Now, I'm going to ask you to try your own, come up with one other one. I put extra blanks in case students could come up with another one, but just pause, complete table for activity 2, do number 2, what patterns do you notice, and then let's head down to the are you ready. Pause, come on back when you're ready. Completing page 841. We're going to multiply 3 to the 7th power. 1, 2, 3, 4, 5, 6, and 7. Multiply repeatedly. I'm going to put parentheses around here. Now, notice here we have a single 3. In fact, some of you might choose to write a 1 exponent up there in the future. It could be very helpful to you. Meanwhile, I'm seeing now 3 is the repeated factor. So 3 is my base, 1, 2, 3, 4, 5, 6, 7, and an extra. Interesting. Both of these happen to have an exponent of 8, but the base is very different. Meanwhile, the next row is given to us 1 to the 5th. Well, wait a second. 1 to the 5th power, and it's multiplied repeatedly 1, 2, 3, 4, 5, 6. And then we're again multiplying 1/5 repeatedly, but this time 2. So that should match up and be an equivalent expression to the others. Finally, wait a second, interesting here how our base is not numeric. Actually, it does stand for a quantity, but we don't know what that quantity is. Thus, we use a variable. I'm going to multiply a to the 4th and take the product of a to the 4th. Oh, excuse me, that first one is a to the 3rd. And then take the product of a to the 3rd and a to the 4th. In this case, a is the repeated factor, a is my base, and in this case, 7 is the exponent. Now again, please be careful if you use the word add in the patterns that you notice, because you're not adding powers here. You are repeatedly multiplying powers. So can you use pointed vocabulary, proper mathematical language to notice the pattern? Pause the video if you want to talk to your partner now. And in fact, let's see if you can come up with 1 or 2 others. I'm not sure it could be 1 or 2 others. I don't know how many different answers there are. That would be an interesting class conversation. I'm sorry I'm not there. Maybe we'll talk the next day. On Word, 3 challenges to wrap up the lesson. Activity 3. In each challenge, 2 expressions are equivalent, 1 is not. I'm going to circle that. Circle the expression that is not equivalent. Explain to your partner why it is not. And if you disagree, you're going to have to discuss it. And actually, that's not the last part. We're also going to go one step further and say, how would you change the expression so that they do have the same value? So 3 parts. Part number 1, circle and identify which one is not equivalent to the others. Part number 2, explain why. Part number 3, change it so that it does work out. All right, I'll do challenge 1 with you. So we have 3 plus 3 plus 3. We have the summation of 5 3s. Then we have, oh, that's the product. Oh, okay. So immediately I notice that the other 2 are equivalent. This one is not. Why? Because it's addition instead of multiplication. So I've just circled the one that doesn't work. I've just explained it's addition, not multiplication. Now I'm going to go ahead and change. If I simply took all those 3s and change it to multiplication, it will then be equivalent to the product of 3 squared times 3 times and equivalent to 3 to the 5th power. Go ahead and pause your video now. Come on back when you're ready. Challenge 2, ladies and gents. I hope that you identified the proper one that does not fit is on the right. If you use the commutative property, 5 times 4 times 5 times 4 times 5 times 4 is still going to be the equivalent of 20 times 20 times 20. So how could we then change that expression at the end? How about changing it to the product of a power? If we made those 3's exponents, then it would be equivalent to 5 times 5 times 5 times 4 times 4 times 4, or 20 times 20 times 20. Challenge 2 accepted. On to challenge 3. Which one doesn't fit? It's the middle one, because 1 times 1 times 1 is in fact 1. 2 times 2 times repeatedly is going to get to be 6. So the one that doesn't fit is the middle one. How could we then change that guy to be equivalent? I would argue if you exchange the base and the exponent, it would work out then to be equivalent. Pause if you need to rewind, watch it again. As we go through this, I want to do this with a little bit of color here. Always recommend color. So let's say we're multiplying 2 powers, and the powers have the same base, but they have different exponents. Now be careful how you say this. The product of 2 powers with the same base, you may add, but you're not adding a's. You're actually adding the exponents. Allow me please to show you an example why that would work. If I were to write 2 to the 3rd power times 2 to the 2nd power, and I went ahead and expanded this out, here's 2 to the 3rd power, here's 2 to the 2nd power. We still have the base of 2, but in this case, if I added, I should have used the same color, shouldn't I? If I added the exponents, that will tell me how many total times that factor is repeated. I could even do the same thing with variables. If I multiplied the product of m and m to the 3rd, well, m times m times m times m. Noticing, please, some of you would like to write that. I can now add those 2 exponents because the product, if I multiply all that repeatedly, will be m to the 4th. I would encourage you guys, continue marking this text. Make 2 examples of your own, please. One with numbers, one with variables. Go and write 2 examples. That's what I got. You may continue into the exit ticket. Miss Moore and the guest teacher should have that for you, and then we'll follow that up with going into your homework. Take care, folks. Do well. Let's grow.